Okay, welcome back to my programming in ARM assembly video series where I'm just trying to put together a simple number guessing game. So let's get back into the code. Alright, and once again, just that. Okay, so when we left off in the last part, which for me was a few hours ago, so let me actually remember what it was that we were doing. So we got to the point where we got this print s function call working correctly. Yeah, I remember now. Had some glitches there, but got it all figured out. The issue ultimately ended up being that I needed to save the memory address of register 1 into register 4, and then we would loop through pulling out all the different bytes, or at least getting the count for all the different bytes, and then right before doing the service call to actually print everything out to the screen, I would then restore the memory address of originally the memory address of register 1, which I had saved in register 4. Come to think of it, there's another way to do that, but it's fine, it's working, so we'll just move on. Okay, so the next thing I want to do is there's a little bit more cleanup I want to do in the main file, but I want to get into this. I want to get to the point where we can hopefully replace the hard coded value for the secret number. And in order to do that, I want to create a new file where we can hopefully start generating, hopefully at least get the framework for the process of generating a number. So let me create a file, and I'm just going to call it random.s because I want to, I mean, of course it won't be a truly random number. We know how computers are, but it'll at least be randomish or pseudo-random. So let's just get that underway. So let's create global, and we'll call it rand, will be the name of our function. And we'll have the rand label here. So we need to open file. We need to open a file. We need to read the file. And we need to close the file. And we're going to need to exit out of this part. And we're going to need our end directive. Okay. So let's look at our system call reference, and I've updated it for opening and closing because these are hard to read. And okay, so to open a file, we need to have the file name. So we need to load. Let me think about this for a second. I think we need to load into register 0 the file name. So actually that should be, let me actually change that really quick. This should really be pointer. So we need to load into register 0 the file name, which we haven't declared what that is yet. And then, and let me just add another space in here now. And then we need to move into register 1. We want to say that this file is going to be read only. And that is the read only is the immediate value 0. And we can set up some defines or some equivalency statements for that later. And we need to move into register 2 the immediate value 0 because register 2, when reading, or I should say rather when opening a file, register 2 needs to contain U mode, and when the file's read only, it doesn't matter, the mode doesn't matter. Okay, so then we need to, so that's R0. So now then we need to move into register 7. We're opening a file, so we need the immediate value 5. But we can go ahead and say that that's going to be, let's just do immediate value 5 for now. And then after that, we need the service call. And we'll just go ahead. For now, I'll just use immediate values, and I'll decide later if I want to do the equivalencies. This isn't our main.s, so I'm not as worried about having like defines or equivalencies. Okay, so after the file's open, so we need to declare that, and then I'm going to need that. So the file name is going to be of type ASCII, and it's just going to be the name of the file. In our case, it's going to be dev urandom. I need to read the difference. I read about the difference between dev random and dev urandom, but now I don't remember what it was. So I need to reread that again. But for some reason, I seem to remember that you want to use urandom, but I don't remember why. So I need to look that up again. And we need a file descriptor. So fd, and the file descriptor is just going to be it's just an integer. So actually we can just say int, and we can initialize it to 0. So actually, after the file's open, we need to store the file descriptor before we read it. Before we do any reading, we need to store the file descriptor. And we can do that with, we can load into, at this point the register numbers don't matter, so we can load into register, actually they do a little bit. Or do they? Let me think. We need to load into register. So register 0 currently holds the file name. Yeah, I don't think it matters anymore, because what we really need is the file descriptor. So we'll load into register 0 the file descriptor, and then we'll store. We can't store back onto ourselves, so we'll store in. Hang on, I got to think about this. We will store. So the store is actually backwards. So we'll store what's in register 0 into R1. Hang on, am I thinking about that right? Let me just move on for now. Okay, now let's read the file. I think that's right. If not, I'll see it in the debugger. Okay, so let's read the file. So in order to read the file, we need to move into register 7, number 3 for reading, or immediate value 3. And we need to move into register 0, but it's not going to be standard in. Now it's going to be, let me think about this for a second. When reading a file, unsigned int fd, the file descriptor. So it's going to be the file descriptor, but we already have that. When we store the file descriptor, we already have that there. So we can just move on to register 1, which will contain the buffer, which we haven't defined yet. So we'll say, and that's actually like a pointer type, so it'll actually be, we need to load into register 1 the buffer, which we'll just say is called buffer. Really creative name. And then we need to move into register 2 the size, and we'll just say buffer size. Okay, so up here we'll say equivalent when we are talking about buffer size, we are talking about this is how many this is how many bytes we need to read. And for generating a random number, especially if it only needs to be between like 0 and 100, we really need 1 byte. So, but for now, let's just say, actually let's do this. Let's say 80 bytes, not even 80. Let's say 20 bytes, and we're actually going to change the file for a moment to a temporary file. Like, and we'll read it right out of the directory that we're in, so we'll just say file.dat as an example. And actually not even 20 bytes. We'll read the first 10 bytes. So let me actually make that file. So vfile.dat, and I'm just going to populate this file with A, B, C, D, E, F, G, H, I, J. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Okay, so we're going to read the first 10 characters out of the file .dat, and that should make it easy to see. And when we examine the memory, we should actually see A, B, C, D, E. That'll make sure this is working correctly. Okay, and then we need to do the supervisor call to actually read it. And then lastly, we need to close the file, although actually, honestly, it doesn't matter because it's open read-only, so it doesn't really matter. But I guess we should be good stewards here and close it out. So to close the file, we need to move into register 7, the immediate value 6. Think about this. And we need to make sure that register 0 contains the value of the file descriptor. So we need to load into register 0 the memory address of the file descriptor, and then we need to load into register 0 the actual value that's contained in the file descriptor. So this will load the memory space, which will be 0x whatever it is, and then this will load whatever value is actually there. And the value is always going to be like 3 or something, 3, 4. I mean, depending on how many files you have open, but I think it starts at like 3. And then we need to exit. Actually, for now, you know what? Let's make this as a separate file for now. We'll make this like its own thing, and then we'll link it in later. And so for exiting, we need to move into register 0, the immediate value 0. We need to move into register 7, the immediate value 1, and then we need a service call so we can actually exit the program. Okay, so I'm actually just going to compile this completely independent of the, I should say I'm going to assemble this completely independent of the main game. So let's assemble this with debugger, and we're assembling the random.s file, and the output will be random.o. I can't believe that actually worked. Thought for sure it would throw back an error of some kind. All right, now let's link the random.o file, and the output will just be called random. Okay, of course that didn't work. Undefined reference to buffer. So, okay, right. Buffer is going to be of type ds.b, which is the same thing that we had in our in our main.s file, and it's going to be of size buffer size, and we're going to fill it with zeros. Although if we don't include that comma 0, it will just default to being filled with zeros. But we're just saying that we want this buffer space of 10 bytes that's full of zeros. Okay, so write that quit, and let's reassemble, let's relink, and now we should have a file called random that segfaults. Okay, so somewhere we're doing something clearly wrong, but let's look at it in the debugger. GDB random, and let's just set a breakpoint at 1 and just run it and step through. Okay, so R0 should contain the memory address of file name, and I'm assuming that's correct. And then we're going to load 0 into R1, 0 into R2, 5 into R7, and then we're going to make the service call, supervisor call, and R0 came back with the file descriptor number that was available, the first one that was available, and for some reason it's always 3 if you don't have, it's always 3 the first time you do it, and I'm assuming if you opened a second file it would be 4 and then 5 and then so on. And then now we're wanting to say we're going to store it, so we're going to load the memory address of that can't work. We're saying we want to load the memory address of the file descriptor into R0, which is going to overwrite our file descriptor. So that's wrong. So let's actually just quit. So this should actually be the other way around. We want to load the file descriptor memory address into register 1. And then we want to save. We want to store for some reason the store instruction, I feel like it's backwards. So let me see if that's right. Okay, so it doesn't segfault anymore, but let's open this up in the debugger again. Breakpoint 1, run, step, 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 step. Now load into register 1 the memory address of the file descriptor, and we'll assume that that's right. Now store the file descriptor, the actual value of the file descriptor, the actual value of the file descriptor into register 1, but I think I have that backwards. But let's step through it and see. Now let's examine the decimal value of the memory address. Okay, so maybe that is right, because otherwise it's storing the value 3 into that location. Now read, now we're getting into the read file, so read, actually that can't work either, that's wrong. Now we're overwriting the file descriptor. No, that's fine. That should be fine. Yep, that's fine. So now load the memory address of buffer into R1, and then buffer size into R2, which was 10, so that's correct. And then the immediate value 3 into R7, and then read the file. When we do this, the supervisor call, we're saying read the file. So now, if that worked, then we should be able to examine the memory location of think about this. we should be able to examine the memory location of the file descriptor in C, A, B, C, D, E, F, G, H, I, J, whatever it was, the 10 values. So 10 character values at this location. And if it's wrong, I think I know why. If it's right, I'm actually might be a little surprised. Actually, it's right. So that worked. So we read the file. That's the point. Although that does actually confuse me a little bit, but but it seems to be correct. Okay, so then we'll step forward and close out the file descriptor. But first we need to load the memory address of the file descriptor into register 0. Yeah, and it has to be into register 0. And now we'll actually load the value of the file descriptor into register 0. So we should see 3 in register 0 when we step forward, and we do. And now we need to move the immediate value 6 into register 7 and then do a supervisor call. I forgot to put on the supervisor call. But it doesn't matter because the file is open read-only, so it's not going to damage anything. All right, so then we'll continue through into the end. So let me, as the last thing, let me just edit this and put on SVC 0 because I forgot to put that there, and that actually closes out the file. Okay, so it actually seems to be working. So let's write this and quit. And then since we're over 20 minutes already, which that went by really quick, we will make vid, I have no idea what I'm up to, make dir vid7, and we'll copy all of our stuff into actually, well, let's just copy everything. No, let's not do that. Let's copy file.dat into vid6. We'll copy main.s into vid6, although I don't think that changed at all. And we'll copy our makefile into vid6. We'll copy print into vid6. And then we'll copy the new thing, random.s, into vid6. All right, so for this video, mainly I just wanted to walk through the process of opening a file, reading from the file, verifying that we were actually reading data from the file, and then closing out the file. So now we have those steps outlined, so now we can replace file.dat with dev/urandom and start reading actual random data. But we'll do that in the next video. So thanks for watching, and I hope you make it into the next video. Thank you. Bye.